Let's take an example and then we will understand more better. So there is a customer who is more interested with sci-fi movie. Okay, a customer, and you can include yourself as well. It's very much interested in sci-fi movie. Now, if I show any sort of comedy movie, if I recommend any comedy movie to this particular person, will the person be interested? Definitely, maybe, may not be. Okay. So, based upon the different persona, the product has to be recommended according, based upon different users' requirements. So now this is one side, like an example from Netflix. Okay, example from Netflix. Then you take an example from Spotify. So in Spotify, you have an option where those recommended songs are there. So what kind of songs do you like? Okay, so those all things. If I'm more focused into, let's say, any sort of classical music, if somebody recommend me very jazzy music, I won't prefer too much, right? I will try to prefer to go further with classical music. So recommendation has to be correct in order to expand your business, that we already know that. And the other side is expansion of business. Other side is adherence. Okay. So there can be any sort of, so for an example, in Spotify, you as a customer, you go ahead and you get to see a good recommendation of songs. And let's say you go and subscribe for a given year. And you are subscribed to Spotify music list. And eventually, what happens is the only thing, once you are converted, once you are already converted to a customer, once you are subscribed, suppose that the only thing comes is adherence. So first is expansion. The second thing comes is adherence. So the adherence is the one where most of the organizations are working. You will be keep on playing in that platform if you love it and if it meets your requirement. So adherence is one of the areas. So most of the product-based company, they actually focus on these arenas. Okay. Next is, let's understand some of the retail example. So Amazon. Okay. Amazon uses product recommendation for based upon your past historic purchases, based upon your past historic purchase or search. Okay, it can be anything. Amazon do have their system where they eventually also give you discounts which are very much streamlined only for you. So it's a personalized model which takes a particular customer and tries to gives a lot of discount based upon their past historic purchase, revenue generation, and the other requirements. Okay. So Amazon is also a very good example. So all of these are the very, very important and very, very good example, by the way, where you are not only utilizing the product recommendation, but also you are deriving a personalized experience. Okay. So based upon your historic search, based on your historic information, your Netflix is personalized to you may not be very well fitted for me, okay, but it can be very personalized to you. For my Netflix, all the recommendation and everything will be very personalized to me. So that way, you actually will have adherence. You will actually have an adherence, and with that adherence, you will actually be sticking as a customer with these different providers. Okay. Now, this is what the business use case is, and not only applicable for these examples, like there are tons of other examples where the similar algorithms are also stepping their benchmark. Now, coming to the important aspect, like how do we solve this problem? Or how do you build this kind of recommendation engine? Okay. So first of all, we need to understand that whenever you are providing a recommendation engine, are you building a user-based recommendation engine, or are you building a product-based recommendation engine? So I will move it to the next slide, where one is user-based recommendation engine. Another is product-based recommendation engine. In user-based recommendation engine, what you get is, in the user-based recommendation engine, you take the historic information of user and then you build the model, or you build a solution. In product-based recommendation engine, what you do is you take a particular product and then look at what are the associated attributes with that particular product. So for an example, you are taking a sci-fi movie, okay? How many users are aligned? How many users are aligned with that sci-fi movie, or want to watch or already watched, okay? How many users are basically aligned? So they are willing to watch, or they are watching. So these are the different type of categories. The sci-fi movie is basically having its own set of attributes, and then these users are also watching some related movie which are also a part of sci-fi movie. So your product should be placed in a way where there is a very minimum difference among the other set of movies with the same category. Okay, so one is product-based approach, another is user-based approach. In product-based approach, what you do is you take a particular product, put it into study that particular product, sci-fi, and then what are the similar attributes that you get to see among with the other products, so that you can sell all of them together, and finally you can put it in place. So that is how user-based and a product-based approaches. In all these approach, in both these approach, user-based or product-based, you can basically use a similar algorithm and you can derive your own set of results. So there is no challenge in that. You can derive your own set of results and you can put a similar approach. The only problem is about the data. In user-based, you will have a good amount of data. Okay, you will have good amount of data, good sample of data. While in product-based, you will not have very good sample of data. Your sample will be not so clear or not so good. Why? Because not all the information with the product-based will be always available. Not all the product will have a good amount of information. Okay, so you need to, it's a kind of a trade-off. You need to choose based upon your problem statement and based upon the availability of data, what approach you have to select. So for those where the users are not available, okay, where you are not sure, you don't have a good chunk of end users. So for them, you cannot use user-based approach. Okay, there will be a lot of scenario where the user chunk is not available. So in that case, you cannot use it. But when you are going with the product base, you don't need user information. You need an attribute. You need a set of attributes which are very similar and which are only focused based upon that product. So in that case, you can go with a product-based approach. Okay. So every approach, and then I will give you a vice versa example. In a product-based approach, let's say product where none of these attributes fits in. Okay. So in that case, you can go with user-based approach if you have a sufficient data. So you have a flexibility in choosing how you want to model your data, means how you want to take the data and then apply different set of logics and get a result out of it. Okay, so data modeling is completely based upon the business use case that you have. And based upon that, you have to choose what algorithm fits in the best. Okay, so let us see what are the algorithms that are available in terms of solving this particular product recommendation. Okay, so if I choose my first preference, what is the first algorithm that I can go ahead with? So there are a couple of algorithms. Okay, one such algorithm is clustering. Okay, one such algorithm is clustering. The second algorithm that I would choose is collaborative filtering. Collaborative filtering. Third I would choose is nothing other than association. Association rules. It is also very, very interesting. Association rules. Fourth, you can also use some deep learning mechanism where you have sequence modeling, deep sequence modeling. One of the best way, if you go with, is either of these four are applicable. One of the best ways, deep sequence modeling is also very good approach, because this approach is good, but in sometimes it also has its own limitations. So we'll talk about all these four algorithms, and we will understand how each of these algorithms plays a key important role in this particular product recommendation engine. And then we'll come to an example, and then we'll see how does it works. I'm not sure how many of you are very good at Python. So I'm not getting too technical, rather I'm trying to keeping more simple. Once you land into our course, we actually go and explain in more technical terms. We try to teach you each and every algorithm and solve all those problems in more detail. Okay, so coming with clustering. Clustering is basically of two types. Okay, so let me move on here. Clustering is of two types. Okay, so one is supervised and unsupervised. Okay, so this is another approach. So generally, you will already have a set of information within your system. So nothing is unsupervised in this case. Means you will have an historic information that what are the movies that you are interested in. What are the different factors that you are more interested with. So you will already have those set of information. Can be a movie, can be any product, can be any given solution in what you are interested. Okay, so that is what is clustering. So in clustering, in case of unsupervised, if you are not having those, as I was explaining, that if you are going with a product-based approach, so you will not have users' information, you will not have those historic information of the user. You will have some set of attributes of that particular product. So for an example, if you are going to recommend a health drink, okay, let's say Amazon is using a model which basically goes ahead and recommend health drinks. So in that case, what happens? Amazon there is two approach. If it goes with the user-based approach, then it will actually filter out who all the users they have basically went and purchased a health drink. Okay. In product-based approach, you don't need that. You need that. What are the factors that a health drink is associated with? Okay. So it's a nutritional factor, or if somebody is going and searching for gym-related context, if somebody is going and searching for any sort of hygiene-related context. Okay. If those are the factors that we need to create from the data, and then we need to introduce over here. Okay. Now, going back here. So this is where your unsupervised clustering mostly helps you. When your target is not known, when the target is not known, target is not known, okay, to business, then we go with unsupervised clustering, unsupervised unsub clustering, when the target is not known. If you know the target, that these are the set of, if you want to go reverse user-based approach, then you have the historic information of the user, and you already have it, and you already know it. So you know if the user is interested, anytime the user was interested with health drinks or not. If the users are not interested, then you can categorize them. And if the users were interested, you can flag them off. So like that, you can basically create different categories and finally build your supervised learning when the target is known to you. Now, how clustering works, we'll explain in more detail. Okay, if it is known to business, then it is fine. Else, if it is not known to business, then go for unsupervised clustering. The data will be different, and because of that, we are going with two different approach. If it is a supervised, then not only clustering, there are other algorithms which also works in a supervised manner. There are other many algorithms which also works in a supervised manner. Okay, so let us understand how clustering works. Clustering works in a very simple analogy of distance calculation. Okay, so it's like your Pythagoras theorem. Okay, so let's say you have a distance, one over here, another over here. You have those values, 2, 4, or in a very simple terms, if I have to explain, it's your x1 and x1, y1, and this is x2, y2. And you actually go and calculate the difference of whole square plus y2 minus y1 of whole square. And you put a square root of it. You put a square root of it. So this is what is your clustering algorithm. This particular mechanism is known as Euclidean distance. This is known as Euclidean distance, ED. If the distance is I, it means that your definition of the product is different if the distance is high. Okay. If the distance is low, means there is a similarity. There is a similarity between the two items. Definitely, it's a similarity. Okay. So this is the baseline understanding of clustering. On top of it, there are different other type of mechanisms like Manhattan, Minkowski clustering distance. Okay. Which we apply it based upon different. But this is one of the basic one where we have where we actually go ahead and get with a very similar strategy. Like if you have another item with less distance, then they belong to a good similarity and they can actually come into the set of clustering algorithms. So similarity measurement is also a part of the second approach, which is collaborative filtering. Because then only if you know how to measure the similarity. So let's say you are basically you are having a set of users. So user US1, user 2, user 3, user 4, user 5. This is movie M1, M2, M3, M4, and M5. And these are the different ratings, let's say. Okay, I'm just putting some numbers. Six, let me keep everything within 5. Okay, so let's say M1, M2, M3, M4, this is your movie. And we have the users. Those users who are movie M1, those users who are looking at movie M1 and giving a particular movie, they have a similar thoughts in that particular movie. They have a similar understanding and the takeaway from that particular movie. Those who are rating 1 in the same movie will have a different approach of consumption of that particular movie. So if you just look at this particular, I'll just mark it with a different color. So hence, it becomes very important for us to basically understand that what are the factors that are important, and that's why. So rating is one of the important factor. So it's a rating based approach. Like collaborative filtering has different approach, item based approach, rating based approach. In item based approach, whether a person, a set of person is purchasing the similar item or not. There is a concept of cosine similarity we calculate among the users. We actually go and calculate cosine similarity. Which basically tells us that if two users are having a similar interest or not. Larger the value means that there is a smaller angle between the two users. Larger the cosine similarity value, or larger the cosine value, means there is a similarity between two users. And higher the similarity means their interest, their approaches are all very good and means are all same and are all related. Okay, so this is how you make use of collaborative filtering, where there is two approach, item based, rating based, depends on what is your business need, and based upon that you can apply collaborative filter. Okay. Now, if you guys have any questions, you can definitely post on your chat box, or eventually you can also unmute yourself and ask a question. Okay. Coming to association rules. So this is an item driven approach. Association rules try to see that what are the items. So what are the items that makes two items associated with each other? So you have eggs and you are purchasing milk. This is a very common example, and you can make use of that common example to solve the problem. So you have eggs, you have milk. Sorry. And so you have eggs. How many people are buying eggs and milk? How many people are buying bread and butter? Bread, milk, and butter. How many of them are buying tea and milk? So that if any customer is buying only tea, then we can recommend them milk. If any customer is buying only bread, then we can give some discount if they buy milk and butter. So you need to understand that if somebody is buying onion, what is the probability that he or she will also buy ginger? So association rules is basically helps us to associate. So for an example, let's come up with another example. If somebody is going and buying, or somebody is watching series A movie, more likely that the same person will go and watch series 2 movie. Okay, you get a series of movies, right? Series like first part of the movie or the second part of the movie. So there is a series of movie. Okay. So it's not only applicable for these retail products, association rules are also applicable for other set of products. So hence, it is very, very interesting in a way. Association helps us basically to understand that what are the associated products, or if a person is buying. So when you go to Mintra, once you buy a t-shirt, it also start recommending other set of t-shirt, as well as it also start recommending the other accessories of like belt, trousers, shoes. Okay. And there is now an option in Mintra where you can buy the entire look. So buying an entire look means you're buying the t-shirt, you're buying the trousers, you're buying the shoes, you're buying the entire look. Right? So it is because many people preferred that, and that has been derived by association rules where you can go and apply those logics. Okay. So this is one approach, association rules. And the final one is deep sequence modeling. And then we'll jump into an example. So deep sequence modeling is an approach where in deep sequence modeling, what we do is we try to understand what is the next event that is going to occur. What is the next product that we are going to buy? That is your deep sequence modeling. Okay. So with deep sequence modeling, you get a sequence of product, or let's say there is a pattern in your buying behavior. There is a pattern in your buying behavior. So there is a pattern in the buying behavior. What is that pattern? The pattern is, let's say you go and buy some monthly items. So every month you go and procure some items from the retail store, right? That is your buying pattern. So every month you will go and buy a bunch of chips, chocolates, biscuit. So if that pattern has to return by next month, deep sequence modeling is the best approach, which helps us to identify those patterns. So not every time you will go out of the box and search. You have some pattern, you have some behavior in searching an item and a product. And that pattern is something this deep sequence modeling does. Deep sequence modeling use an approach of neural networks, okay, which basically helps to go and collect set of sequence from your purchasing history or buying pattern or your search. And based upon that, it goes ahead and predict what will be the next set of sequence. And based upon that sequence, it helps you to recommend a product. That is what is deep sequence modeling. Okay, so buying behavior, we are capturing, we are training that buying behavior, and finally, we are predicting that pattern and recommending that set of sequence. We call this as a deep sequence model. Okay, so neural network is a very big topic, and we actually get into there are tons of different types of neural network, and we teach these context in more detail and mathematical form, and then in a practical form in our regular course. You can join our course if you like it, if you wish to learn. Moving to our, now let's go to an example and see how does our different type of parameters works. Okay, so here we have a list of information, list of data. So this is our data, you can see, where the data contains different type of, so let me come here, different type of orders, their values, order value. Okay, and then you can also look at what is the date of delivery. Okay, and what's the product category, okay, whether it's an automotive or any food item or any decoration items and all those. And we have a bunch of comments here and the review timestamp. So this is your data. So you have the product name, category, you have the product type, you have the value of the product, okay, and all those are pretty much available here. Now, what we have to do is we have to take this set of information, create a different type of features, and then finally build a model which is best suited for it. Okay, so I'll just directly go into what are the different type of features that we are focusing on. So one type of feature is how each of these customers are distributed in a geographical location, because that is more important. Some of the items, maybe I am liking it, but that item is not really deliverable in my address. Okay, so I'm liking it, but it is not deliverable in my address. So I can recommend some additional item which has a similar properties which is deliverable in my zip code or which is deliverable in my address, so that I don't lose out that customer, and I do also get a benefit of adherence, as I was explaining at the beginning. Expansion and adherence, these are the two important things that comes to any given business. Okay, so in the zip code analysis, the zip code needs to get loaded. So what we understand that from the zip code analysis, that the company is having the expansion in West and North Brazil. Because of the low income group, there are only few markets that are available. Okay, and the interests in customer is very low. And these are the range, latitude and longitude range. So you need an API so that you can visualize it. The visualization is currently visible because the API is not always accessible. But from the results, we got latitude 23, longitude 46, latitude 22, longitude 43. These are the regions, from this region to this region, where the business can be expanded, and currently the customer is comparatively on the lower side. Now let us see accuracy on delivery estimation. This is also one important factor. Let's say if I'm saying that the product will be delivered in next 15 days, then but it is getting delivered after 20 days, then definitely my need as per the customer requirement is not fulfilling. But if I can estimate this with a higher accuracy earlier, then definitely my product will be delivered on time. And also, if I'm not able to deliver by the requirement of the customer, I can also show some additional product or recommend some other set of product with same behavior and pattern. So hence, order delivery and all these other factors are also the very important part. Okay, so what we have done is we have basically taken some number of days in numbers like 0 to 3 days, 3 to 7 days, 7 to 14, Okay, 14 to 30. These are the different. These are the different type of days that you have. And then what we are doing is we are creating a bins. So you can see that 7 to 14 and 14 to 30 are the majority of the chunk where our order is getting delivered. Now, the main delay of the orders, where this is just an opposite of what our delivery is happening, and this is the delivery getting delayed. So we can see majority of the delays are between 1 to 3 days, 4 to 7 days. Okay. So this is a very important factor for those set of orders where there is a significant delay. We try to recommend a different set of product. This becomes a very important feature. And those where our delay is less, means only this blue part, the top 5,000. In that case, the delay is less, and hence the product will be delivered on time. So leaving those set of customers, the other set of customers, we set a different set of benchmark. Okay, so next is promotion timing. So these are the different features, and we are doing an exploratory analysis on each and every features. And finally, we build a model. Promotion timing. So promotion timing, which is the best promotion timing? Okay. And by when mostly the people get converted. So let's say you want to buy a mobile phone. You don't buy on the day one. First, you go and do some research on that product, and then you come back with your setup product, and then means you come back with your setup information, and then finally after 5 or 6 days you go and purchase. So if you know that bandwidth, that this order will be purchased after 5 to 6 days, then definitely it's going to be very important to understand on which day you are currently at. If you are a 5th day, you need to showcase a product which really the customer is interested in. If you are on a 0th day, you don't have any historic information of that product, so you don't need to recommend anything. So what is the best day that you can go and basically apply the promotion? So first is, here it is saying that on the 0th day, you show that these are the products that we have on offer. So the customer can curate based upon his requirement and can choose any of these products in the cart. Once the product is chosen in the cart, then the next is how can we execute that cart items to get purchased or to get converted into. So choosing a product and adding into a cart is a kind of a lead. So we have a lead, now we need to convert that by giving some additional discount or showcasing that you are already at a higher discount bracket. Okay. So this is the best way, best approach. Okay. Next is, this is not so important, best month. There is nothing as such best month until there are some events like Diwali, Christmas, New Year. These are some events where the people go and purchase more. So this is referred as a best month. Consumer behavior can be derived by these three: recency, frequency, and monitoring. How frequently they buy, what is the latest time they have bought, and what is the monetary value that they have. So recency, frequency, and just a minute. So recency, frequency, monetary, and tenure. Okay. So recency, how frequently we are buying. Frequency, how frequently, how recently means from the current purchase, how many days before we have purchased. Then we have the monetary value. Frequency means how many times we buy. Then we have the monetary value. And then we have the tenure, for how many days I am associated with. What is the tenure? So combining these three, we can basically go and give some ranking system to every customer. Okay. Like I have done over here, some ranking system based upon recency, frequency, monetary, and tenure. And the other way is take these three information and pass to a clustering model where you get a definitive result. So I will quickly show you one clustering approach, and then you will get a clear understanding of it. So you can see in the clustering results, we actually landed with five type of customers, sorry. In this, we landed with 5 type of customers. So one set of customers where we have their annual income is very less, spending score is less, almost equivalent. You see the orange category where the annual income is very high, spending score is also high. See the red category, annual income is high, spending score is less. So these are the customers, if I give more promotion, can transfer from red category to orange category. And you see the blue category, they are earning less, but spending more. Even if I give promotion to this blue category, they are not going to give us any revenue. So the red category customers are the one who will give us revenue because their income is high and spending capacity is still there because their spending score is less. So like this, we go and land into an analysis, creating a set of feature, land into an analysis and give a result based upon business outcomes. Any questions, any doubts you have, so that I can explain? So far, any doubts, any questions? So this is how your overall product recommendation system can be designed. Anybody, any questions, any doubts? Okay. No questions, guys? All good? Are we all good? Over to you, Kunal. Thanks, everybody, for joining. Over to you, Kunal.
Yeah, thank you so much, Rishabh. Hello, friends. I'm back again with this session. So, guys, are you able to hear me out? Am I reaching out to everyone? Are you all able to? Am I audible to everyone? Guys, I would be needing your